Okay, in this video we're going to be looking at electronic structure, which simply means drawing the electrons for an atom. The first thing we need to know is how many electrons our atom has. So if we have a look at the periodic table, you'll see that each different type of atom, each element has got two numbers, a larger number and a smaller number. The smaller number is known as the atomic number, and that's actually the number of protons that the atom has. But in a neutral atom, the number of protons will be equal to the number of electrons. So if we look at hydrogen, the smaller number is 1, so it has 1 proton or 1 electron. Helium is 2 protons, 2 electrons. Lithium 3 protons and 3 electrons. Okay, next we need to think about where we draw these electrons. So there are a few rules for where to draw the electrons. The centre of an atom is called the nucleus, and that's where you find the protons and the neutrons. And around the outside of the nucleus we have areas called shells, and that's where you find electrons. So these are our rules. The atomic number is the number of electrons. We fill the inner shells first before moving to outer shells. The first shell holds up to 8 electrons, and for GCSE you can think of the other shells as just holding 8 electrons. Okay, so let's use those rules and try and draw the electronic structure of an atom. If I pick lithium, the smaller number is 3, so it has 3 electrons. I'm going to write Li just to represent the nucleus, and I'm going to draw a circle which represents my first electron shell. Now I've got 3 electrons total to draw. The first shell can only hold 2 though, so I can't draw all 3 electrons in this first shell. I can only draw 2, and I can draw represent the electrons by drawing a little X. So I'll draw an X here, I'll draw an X here. That's 2 electrons, which means the first shell is full. I'll draw a second circle to represent the second shell, and I've got 1 more electron to draw because lithium has a total of 3, so I'll draw that there. And that's it, that's done for lithium. Another way of displaying this is, rather than drawing circles for electron shells, we can write a list of numbers separated by commas. So lithium has got 2 electrons in the first shell, so I can write 2. And to show that I've moved to the next shell, I'll put a comma. And it has 1 electron in the second shell, so 2, 1 is the electronic configuration of lithium. Right, let's have a go at a few more. If I use my periodic table, I can see that helium has 2 electrons, so I'll need just 1 shell, 1 electron, 2 electron. Its electronic configuration is 2. Nitrogen, smaller number is 7, so it has 7 electrons. So I can fit a maximum of 2 in the first shell. I've got 5 left, so I'll draw a second shell. 1, 2, 3, 4, and then we start pairing them up. 5 electrons for nitrogen. Sodium, 11 electrons. 1, 2, second shell. 3, 4, 5, 6, 7, 8, 9, 10, but the final electron can't fit in this second shell because the second shell has now got 2, 4, 6, 8 electrons and it's full, so we need to draw a third electron shell and put the 11th electron in that shell. Okay, so let's write the electronic configuration for them as well. Nitrogen is 2, 5, sodium is 2, 8, and then comma, move to the third shell, 1. Okay, calcium is the biggest atom you could be asked to draw. It has 20 electrons, and you won't be this would be the most difficult one you could be asked in your exam. 2 fit in the first shell, 8 in the second shell, 8 in the next shell, and we've got 2 left that we need to put in the 4th shell. So calcium would be 2, 8, 8, 2. Now if we have a look at these atoms, there is a big hint as to their electronic structure from their position in the periodic table. Helium is in group 0, the final group, and you'll notice that every element in group 0 has always got a full outer shell of electrons. So helium's outer shell is the first shell, and it's full with 2 electrons. Every atom in group 0 will have a full outer shell. That makes them very unreactive because they already are stable with a full outer shell of electrons. If we look at nitrogen, it has 5 electrons in its outer shell. And if we find nitrogen in the periodic table, it is in group 5. So everything in group 5, nitrogen, phosphorus, has got 5 electrons in its outer shell. If we look at sodium, sodium is here in group 1, column 1, and it has 1 electron in its outside shell. And calcium, well, we can see that calcium has got 2 electrons in its outer shell. So straight away we know that calcium is going to be in group 2. And if we have a look at the periodic table, group 2, calcium. So the group number, the column number, tells you how many electrons are in the outside shell. Okay, something else the periodic table tells us. Each one of these circles that I've drawn is an electron shell. I've drawn 1 for helium, 2 for nitrogen, 3 for sodium, and 4 for calcium. This is equal to the row or period number that each of these elements is in. Helium, 1 shell, it is in period 1, the first row. Nitrogen, 2 shells, it is in period 2, period 1 there, period 2 here. Sodium, 1, 2, 3, so it must be in row or period 3, 1, 2, 3. And finally calcium, 1, 2, 3, 4, and it is in period 4.